Well, welcome back. In this lesson, we'll be discussing the health impacts of EMF, specifically on children. This will be done in two parts. This part will be an overview of the physical effects and how children are more vulnerable to specifically the light and radiation. So in this lesson, we'll learn why children are more vulnerable than adults, how blue light impairs cognition and development, and how blue light disrupts our hormones. So why are children more vulnerable to EMF? Well, a child's brain contains more fluid and less fat, so it absorbs more microwave radiation. As you know, fluid is electrically conductive. Fat tends to impede electricity because it's denser. That's just one little fact, but the kids obviously have smaller ears. The cell phone on the ear is going to be a lot closer to the skull because adults, we have larger ears, obviously, and more of a gap, more of a barrier, more bone than a child. And obviously, as well, children have smaller heads, so there's even a shorter distance to that brain center. And a child's skull and adjacent tissues, they're more similar, so more uniform than an adult. So with an adult skull, you have different, more diversity in the brain, more membranes, more bone, and there's just more folds in the brain. It's just more developed. So that actually causes more reflection to occur at the interfaces of these membranes in an adult's brain. Think of a window, right, in your house, or anything that has a lot of different surfaces. It's going to reflect. So just to kind of explain it to you simply, so a child's brain is just one uniform mass. So those microwaves or electromagnetic fields can pass through very easily unimpeded. Whereas an adult's brain, on the right there, you can see it has a lot of complexity there. Not to say that an adult obviously isn't affected, it just has a lot more to get through. Okay, there's a lot more mass. This is a screenshot from an article done by Fernandez, cited in Environmental Health Trust in 2017, and just shows the radiation exposure between an adult and a child. They actually tested this, and the bright yellow is the highest absorption. You can see it penetrates deeper into the child's brain, and the black on the scale all the way on the bottom, that's the lowest absorption, but that is still being absorbed. You can see all the way on the right here, it's passing all the way through the child's brain unimpeded. That's between an adult male and a 6-year-old child on the right. Okay, and this is just at 9 gigahertz, so that is a weaker signal than our Wi-Fi, which is 2.5 gigahertz. So how does blue light impair cognition? Well, we have B12 photoreceptors in our skin and eye. Yes, that's right. Vitamin B12 we have in our skin and our eyes. And that is very important because B12 myelinates our nervous system, basically develops our wiring, our nerves. And excessive blue light exposure and photoexcitation basically just means your body is being stimulated with electricity and light. That has the ability to deplete B12. And when this happens, blue light also will destroy melatonin, dopamine, as I mentioned, B12, DHA, which is an ancient omega-3 fatty acid that regenerates us while we sleep. It'll also destroy the concentrations of DHA in the retina. And this happens through a photoreceptor that we have in our retina. We have rods and cones, as you know, but we have also what's known as melanopsin. And melanopsin is very crucial in being able to help us regenerate by secreting melatonin and absorbing the right amount of light throughout the day. And we're going to get into melanopsin just a little bit later in this slide. But dehydration also occurs because if you remember the slide with the electron transport chain, our mitochondria and cytochrome C oxidase, need full spectrum sunlight. And if you don't give them that, and they're missing the red and infrared spectrum, they won't be able to complete the cycle. And when cytochrome C oxidase is broken, we can't generate the right amount of electricity in our body, which will allow us to power our metabolism. And basically, the mitochondria keeps the water from what we drink and in our cells in that membrane. And the sun charges that water like a battery. Okay, so we need that full spectrum sunlight. If you get blue light, it's not going to charge that battery. Okay, eyes. Our eyes are all densely packed with mitochondria. We have a lot of mitochondria. In our eyes, our hearts and brains are loaded with mitochondria. Now, children under 10 years of age absorb 60% more blue light into their retina because their eyes are not yet fully developed. And just to give you an example, so this is a retina age 10 years, and you can see how the blue wavelength, which is 400 nanometers, 460 nanometers, but right between there, it's almost 82% absorption. The 460 nanometers is getting in 60% down into the retina. Okay, so it's getting almost all the way down deep into the eye. Versus an adult, it's usually stopped closer to that midline on the retina. Okay, so don't let your child's brain become an open door to all these frequencies. And children are just developing. They're in a creative state, okay, that needs to be fostered, and we're going to talk about that in the next lesson. But a child's brain is mostly fluid. That's why I put the light bulb there with the water, because it needs to be nourished, okay? And yes, there are lots of things that maybe we can't control right now. You feel powerless, like with the satellites and power lines all around you. But take the steps you can to control your electrical environment. Okay, you don't need to have those Wi-Fi routers. You don't need to have the cell phones. You can go hardwired, and this is what this course is all about, because we're going to help you do that in a later module. So the big picture here is, if you look all the way in the back, that's the sunlight that we grew up in, we lived in as a species for hundreds of thousands of years. We received all that energy, okay, from those different colors. Now, if you look further closer to the screen, you have LEDs, okay, you're getting a lot more of the blue spectrum. You're not getting as much of the red, and in incandescence we get a lot more red, which is good because red helps us repair, and we're going to get into how light can help us repair in a future module. But this is just to show you how much we're being starved of our mitochondrial food, of our actual energy we're not getting. Okay, so light is not a replacement. Man-made light is not a replacement for true light, which is sunlight. Okay, so remember the photoelectric effect. Okay, we need the sun to then work with our water. It splits apart the water molecule into hydrogen, oxygen, and it creates two electrons. Okay, and this is what gives us ATP, adenosine triphosphate, and that's what gives us energy. Okay, so what do you think is going to happen if you put your child in a classroom or they're just on their computer all day indoors? They're not going to get the energy they need. They're going to get dehydrated and they're going to be sluggish. This leads to all kinds of things: depression, insomnia, and as I'll show you in a future lesson, weight gain as well. So the example of the electron transport chain can be simplified again here. But now the conductor on the top left, he's not all sunny and happy. He's this blue light ghost that he is being stalled. He can't move the train because he doesn't have enough energy. Those red train cars, they're not getting any red light. They're getting blue light. Okay, and when that blue light hits those train cars, that ATP can't be generated because we're not making enough water, really. Okay, that water molecule and all the water that is in that mitochondrial membrane, you'll see in the bottom right of the screen, it's become very sluggish. Right, it's not moving. We're stuck in the mud. So, how does blue light impair development? Well, as I mentioned before, melanopsin, which is a photoreceptor, that's what it looks like on the right. It not only regulates the amount of melatonin that we ultimately release at night from our pineal gland, but it also supports apoptosis. So why is that important? Well, apoptosis is cellular division, and cellular cleanup. And when we clean up our cells, that's a way to get rid of, well, just unwanted garbage, right, that our bodies don't need, either in our brains or in our muscles. And when that doesn't happen, well, things like cancer can happen, and all kinds of disease, right? You need that apoptosis to stay regular, fresh, and regenerated. And this also destroys our circadian mechanisms, which tie to our metabolism, and everything we do throughout the day is based on that circadian rhythm. All right, so blue light destroys melanopsin, which controls the circadian rhythm. And melanopsin controls it by determining when the optimal time for sleep is. It's like our dimmer switch. We see the sunrise, it gets activated. We see the sunset as things start dimming around us. Our eyes, the melanopsin, sees that light frequency, wavelength, and it knows that it's time to power down. So it keeps track of sleep pressure and how long we're awake, and it's our trigger for rest, especially when we're overtired. And what happens when we lose that trigger? Well, we'll just keep working. Obviously not good for a child or yourself. Now, when we absorb a lot of EMFs in the form of blue light, which tend to be very high energy, that blue wavelength is a shorter wavelength, so it's very intense, it's packed. If you remember in the light module, I showed the different wavelengths and how they work. If you don't remember, that's fine. I suggest you go and get a refresher. But we also destroy our stores of retinol, which is a form of vitamin A. And why is that important? Well, we need vitamin A to make all of our hormones. Okay, thyroid hormone, progesterone, testosterone, growth hormone. So you think it's a good idea to have a child in front of this blue light because all the hormones are going to be wrecked. Okay, this is how this works. So another very concerning fact is that once your melanopsin receptor is desensitized, that enzyme, that pathway of vitamin A, has the potential to be irreversibly damaged. Okay, so you may be signing up your child to be partially blind or have glasses their whole life. Okay, this is serious. Also forces an important prohormone, which prohormone makes other hormones, pregnenolone, to be switched to cortisol production. So get switched to stress. And pregnenolone makes other hormones. DHEA, vitamin A and D, testosterone, estrogen. So when this production is disrupted, all these hormones, all the levels fall dramatically. Okay, and these hormonal imbalances obviously can lead to all types of mood disorders and autoimmune disease. So melanopsin, as we were mentioning, it's particularly sensitive to blue light. Okay, you can see it's blue in the center, so it likes to reflect certain blue wavelengths. It does absorb some, but just think of it as the blue light sensor. Okay, it communicates this frequency to our suprachiasmatic nucleus. All right, and why is that important? Well, because our suprachiasmatic nucleus is our master clock. It dictates all of our rhythms throughout the day. When we're hungry, when we're tired, when our cells should repair, or when we should go through that apoptosis. Even our lymph nodes are activated by this clock. And in the next module, in the next lesson, we'll get into how the blue light actually leads to addiction. Because dopamine, it's known commonly as the pleasure chemical, right? But it's actually really not that. You can think of it more as the chemical of more. That once you do something, you want more of it. Okay, it is a pleasure chemical, reward sensor, this and that, but the implications of it being the chemical of more are even more profound, because not only do you want that thing more, you keep doing it every single time, right? So it doesn't satiate you. You just want more of it. So there is no end to that cycle. Once you get on that dopamine blue light train, it's very hard to quit. And to further compound that, blue light actually gradually depletes dopamine. Okay, so you want it more and more and more, and then you can't even make it. So it becomes a very, this is how neurodegeneration happens. This is how things like Parkinson's happen. So are we consigning our children to become, to have Parkinson's disease at 11 years old? This is just my theory, but it doesn't look good from this angle. And blue light also activates an enzyme that's designed to lower dopamine called monoxidase. I'm sorry, I'm mispronouncing that, but it's MOAB. Okay, and that's the science on that. So thanks again, and please, if you have any questions or comments, leave them in the lesson. I will link to all of the on the article with the melanopsin and the blue light, so you have that source as well as the MOAB.